So last time we were talking about finding the inverses of a function from its equation, right?
Yes.
So I can't believe there's not a way to just get rid of this thing. So we were looking at a couple of examples. The second example we were looking at was this one, and we had gone ahead and found its inverse. But I want to do a little bit more on here. So what if I want to check to see if these two, if what I found is actually its inverse, right? So we have a function f and a function f inverse. And I want to check to just make sure that those are indeed inverses. How can I do that? Yeah, good. We're going to do the composition both ways. Yep. So when we do these compositions, what are we hoping this is going to simplify down to? Not 0, x. So I'm going to do f of f inverse. So my function f said 2 times x. In place of x, I'm just going to put the big parenthesis. Plus 5 divided by 5 times big parenthesis minus 8. And what's going inside the big parenthesis? That f inverse piece. And yuck, what do we have here? We got like fractions inside of a fraction. Yuck. Do you know what this thing is called when we have fractions inside of fractions? It's not fracception. That was an Inception joke for you guys. I don't know if people still watch that movie or not. It's called a complex fraction. It's pretty good. Very stylish. Not really relevant to what we're doing. But I think if you take psychology, you watch it at some point. All right. So what do I want to do to simplify something like this? Here's the trick. My big problem is I got these fractions inside of fractions. That's going to be my first order of business to get rid of. Yes. The numbers on the outside. So my function here is 2x plus 5 over 5x minus 8. That's what I'm plugging into.
You put the inverse into the
yeah,
original.
exactly. And I guess I should really call these h's, huh? That's what I called it before. Let's not confuse anyone. There we go. That's probably a little clearer. Okay. So what I want to do first is I want to take care of the fractions inside of fractions, right? A fraction is bad enough on its own, but these fractions inside of the fraction are just like making my head ache a little bit. So here's the trick. Is what I'm going to do is I'm going to multiply the top and bottom of this fraction by something. Okay? The something that I'm going to use is going to be the least common multiple of all the denominators. Now in this problem, I just have really two different kinds of denominators. I have 5x minus 2, and then I have 1, right? There's a 5 over 1, 8 over 1. The least common multiple of 5x minus 2 and 1 is just 5x minus 2. So that's what I'm going to multiply to the top and bottom of this fraction. Everybody's okay there? That's going to distribute then to each term. So when I multiply 5x minus 2 to 8x plus 5 over 5x minus 2, the 5x minus 2's just cancel out. No more fraction. And then I'll multiply it to the 5, and I'm just going to write it this way. And the same thing's going to happen in the denominator. Yes, Boyd?
So when we started, why did we switch 8 and 2 for like the 8x? Like we switched that for.
So my function h is this. That's what you're plugging into.
Oh, okay.
So I didn't switch anything. I just was using h because we're picking up from a problem we started last time. Is that okay? Okay. But look at what's happened since I've done that. What did I get rid of? One layer of fractions, right? Now we just got one single fraction. That's an improvement. Everybody agree? Okay, what do you think I want to do next to simplify this thing? Yeah, that's right. So we'll distribute. We got a whole bunch of distributing to do, but that's okay. That's pretty easy to do, all things considered. Yeah, the fun stuff. Because what are we expecting to get here at the end?
Just the x.
Just an x. So I want to point out to you that the place that we have to be careful is when we're distributing. We want to make sure we're distributing a negative 8. That negative sign needs to go with the 8 when we do that distribute. Easy thing to forget. Everybody's okay with how we distributed there? Boyd?
So when you distributed the -8 and -2, how did you get plus 10 out of that?
Oh, should be 16, right? Thanks.
That Boyd.
Yeah.
I'm gonna pretend that 0 just looked, or that 6 just looked like a 0. I just made a mistake. All right. So what next?
Combine.
Yeah, combine like terms. So the plus 10 and negative 10 go away. The plus 40 and negative 40 go away. And I'm left with 41x over 41, which just reduces to x. Now, the first time going and doing something like that, that was a little rough, right? It's kind of a lot of algebra going on there. Let's do the reverse direction. You're going to see that feels a little bit more familiar, at least, when we do it again, because it's ostensibly just the same problem. So remember that our original problem here, h, was 2x plus 5 all over 5x minus 8. So h inverse was 8 times x, I'm going to put a big parenthesis there, plus 5 all over 5 times big parenthesis minus 2. And in place of my big parentheses, I'm going to write 2x plus 5 over 5x minus 8. Please stop talking. Thank you. Okay. So there's the composition. Another complex fraction. That's okay. What was the trick to getting rid of the fractions inside of the fraction?
Multiply.
You gotta do the fun stuff.
Yeah, multiply by 5x minus 8. Okay, when I distribute that stuff through, got that. What do I do here? Distribute. Just feeling a little bit more familiar now, going through it a second time. Obviously, the numbers are a little different, but the process is basically the same. And we combined our like terms. Oops, not that. Those are the guys. Which just simplifies down to x. There we go. Everybody okay there?
That's pretty cool.
Yeah. That's kind of algebraically as difficult as these get. I'm going to still do a couple more examples, but I think this one is the worst algebraically. All right, let's say we want to find the inverse for 3x squared minus 4. So remember to find the inverse. My first step is to replace the f of x, the function notation, which is the y equals. Everybody good there? Then we want to get the x by itself. What do we do to get the x by itself in this case? Add 4. Then what? Divide by 3. Can I do that all in the same step for you guys? Square root both sides. Good. When we square root both sides of an equation, what do we have to worry about?
Make sure you cancel out the square.
Something before I do that.
Make sure the bottom is 0.
Before I do that.
Before I do that, no negatives, right?
Before I do that.
Do that.
The Y.
Oh, plus or minus.
When you square root both sides of an equation, it always generates a plus or minus. If you square root both sides of an equation, it always generates a plus or minus. If you square root both sides of an equation, it always generates a plus or minus. I want to say that 3 times because kids forget. Okay, so the squared does cancel the square root. Everybody's cool with what we have here? Then we swap our x's and y's. That's the third step. And then rewrite this with, instead of a y equals, we'll use that inverse notation. When you look at that inverse, what do you notice about it? Should be something that jumps out from homeworks you guys have already done. It's not a function. What about this is the giveaway that it's not a function? The plus or minus. So for example, if we have like x is 0, 4 plus 0 is 4, so you'd have the plus or minus the square root of 4/3. You have 1x going to 2y's. So we know immediately the plus or minus should be hinting at us that this is not a function. Should we have known that this was not going to be a function before we even got going?
Yes.
Yeah, how would we tell?
Because you double square root.
Well, if I think about what kind of function is 3x squared minus 4. So that's the shape of the graph for it. It's a quadratic because it has a squared on it. The graph of a quadratic, as Boyd has suggested, is a parabola. And I know that this fails a horizontal line test. And what does that mean? Well, f of x is not 1-to-1. And that means then that f inverse is not a function. Everybody's okay with that? Now, what if we said, oh boy, that's a problem. I want to make sure that my inverse is a function. What could we do here? How would we have to change the original problem so that when we take, or when we create our inverse, that inverse would then be a function? We got to make the original function 1-to-1, right? If I can make it 1-to-1, then we'll be all set when we do our inverse. Everybody agree with that? So I'm either going to have to take just this side of my parabola or just this side of my parabola. Does it matter which side I take? No. Which one do you think would be the better side to take, though, yellow or green? Green. Why? Those are all positive x values. Yeah, that's dead on. So let's say, for example, then, we have instead said 3x squared minus 4, where we're going to take only the x's that are greater than or equal to 0. So the domain for my function I've restricted. That's what we've done there. So when we do this, we're just doing the same steps as above till we get to here. Now, because I know that x has to be greater than or equal to 0, what can I do? We have the equation x equals plus or minus the square root of x plus 4 over 3. Because I have x being greater than 0, what can I get rid of? The minus possibility. Oh. That was kind of a lot of work, Mr. Kulik, just to get to dump off the plus or minus, which I probably would have forgotten anyways. That would have been our answer if we had restricted the domain. Now, why, Mr. Kulik, that seems like a really nitpicky detail, like who really cares? Fair, but this restricting of the domain that we've done here, we're going to do that exact same thing later on in chapter 4, I think, where when we talk about inverse trig functions, we have to do the same sort of restriction, because sine, cosine, tangent functions, none of them are one-to-one. So when we build their inverse functions, we're going to have to do this same restriction. And then every time we use one of those inverses to solve, we're going to have to keep in mind that we're going to maybe make some adjustments to our answers based on that. Patrick?
So if we didn't restrict it on it would be unsolvable, right?
It's not that it's unsolvable, it's just that you're getting lots of answers, right? So your inverse is just not really a function, and that's something that you can't program into a machine. You can't, machines have problems with something that's not determinate, where it's this gives you this and only this, rather than this gives you this, or this, or this, or this, or this. Just a computer doesn't do real good with that kind of uncertainty. You know what I mean?
Yeah.
So that's the bigger issue with it not being a function, is now it's going to be a problem to use it to do anything. Okay, and let's do one more example here, and then I'm going to stop. Got to turn my page to see what that example was. So let's say we want to find the inverse for g of x equals the square root of 12x plus 5. Start the same way. Replace our function notation with y equals. Okay, now we want to get the x by itself. What do I need to do to get the x by itself? Nope, not adding 5. Why couldn't I? You'd really want to say subtract 5.
Yeah,
But-
that's what I asked.
But we can't do that because the square root's in the way. We have to get rid of that square root part first. So what should I do? What's that, Emma? You were saying something. I'm not asking you because I thought you were saying the wrong thing. Oh, no, that's a problem. So just as an aside, you can't break a square root at an addition or subtraction symbol. Square roots do not distribute. That is very bad. Okay? The only operations that you guys know about that distribute is multiplication and division. If you try distributing anything else, you're wrong. So square roots, exponents, trig functions, logs if you had seen them, which you haven't. None of these things distribute. Multiplication, division only. What do I need to do to get rid of that square root, though? Caden, did you have an idea? I thought I saw a hand. Oh, okay. What did we use to... We used the square root over in this problem. What did the square root do? Canceled what? A squared, right? So what are we going to use to cancel a square root?
Square root.
Not square rooting. Squaring. We're going to square both sides. Everybody's okay with that? Hopefully that seems obvious now that I say it.
Yeah.
Then we just have to get the x by itself, so we'll subtract 5 and divide by 12. Swap our x's and y's. And write it with function notation. And that's Dunzos. Olivia.
Can you just swap your x's and y's?
That's part of the finding the inverse procedure.
Okay.
That's not something we do all willy-nilly. We're doing
Still
that that's part of the procedure to find the inverses. So again, the steps are like rewrite with a y, get x by itself, swap x and y, and then rewrite with like f inverse of x. So those are the steps. Sure. Okay. That wraps this. We got a test coming up. Let's talk about what the test format's going to look like, so you guys have a good idea of what it is you'll have to be doing. So the first 4 questions I'm going to give you and ask you if the represents a function or not to explain your answer. So just yes or no if it's a function, and then some kind of explanation as to how you knew. Sounds just like the first couple of homework problems, right? Okay. Then we'll have 2 questions where I ask you to find the domain and write our answers in interval notation. Again, we did that on the homework quiz, right? The most recent homework quiz. I asked you to do that.
This be on Monday?
That's the next time we meet.
Yeah.
Yeah. Okay. We'll figure it out. If we need to move it, we can move it. I'm not worried about that right now. I'm worried about talking about what's going to be, what I'm going to ask you to do. So one question where I'm going to give you a graph and ask you to label the extreme on the graph. So absolute or local, max and min. and then to write the intervals of increasing and decreasing. I'll label the coordinates for the points for you guys to use for the extrema, so it should be easy to write those intervals. So you have one question. I'm going to ask you to use your calculator to find the extrema. And then I'll give you a picture of what your calculator should look like. And you'll label them again on the graph as local or global maxes and mins. So you get one question then showing something is odd or even or neither. So you're going to find all vertical and or horizontal asymptotes and then support your answer with a table. So you have two questions where I'm going to I'll give you some functions and ask you either like add the two functions, subtract them, multiply them, divide them, take the composition of them, something like that. Okay, certainly. So that's the test format there. Any questions about the format? Okay. Yes.
Can we go over the asymptotes one more time?
Yes, but give me a second to do that first, since I'm just asking about format right now, but we understand what I'm asking and kind of asking for in these questions. Okay. Where's that? I thought I did that. Okay. Let me do this real quick. So I'm dropping into the OneNote right now set of review questions. And along with those, I'm going to drop in the solutions. That's weird. Oh. Okay, wrong file. No problem. Okay, OneNote, go ahead, take your time. There you go. Okay. So again, solutions worked out more or less. Everybody okay with that? So again, this is the review is just to kind of give you an idea of like the way Mr. Kulik would ask questions and format questions. Maybe everything on my list didn't make it onto the review, but it's got to be pretty close. Everybody's okay? Okay. Additionally, with the test, does anybody remember what you get? Yeah, what more than a note card? Half sheet of notes, right? For the test. You can write on both sides. You can put anything on it you want. So equations, definitions, examples, homework problems, review question problems, whatever you want to put on there. It is your note card. Everybody's okay with that?
Yes.
Those need to be turned into me prior to the test. Ordinarily, I would make them like due at the end of the review day, but I've chewed up a bunch of our time because we had some 1-7 stuff to kind of finish here. So let's say by the end of the day tomorrow for the equation sheet. So you don't see me tomorrow, so you'll have to make a point of stopping back and handing it to me. Does that seem okay with everybody? Reasonable? Yeah. Before, I would say one thing to double check on your review sheet or your equation sheet, make sure your name is on it. I know that seems like a dumb thing to remind you, but you'd be surprised at how often somebody turns one of these things in with no name on it. It happens a fair bit. Any other test or test-related questions? You said Monday was a mass day. Let's just hold on. Just let me confirm that. Jeepers creepers. Hold on a second.
I know. I just have a question.
Okay.
How big is the half sheet? Like
So like
half sheet of paper?
So like your standard 7.5 by 11 sheet of notebook paper.
Sorry, I just.
So it's not. So you can't take like half a poster board, right?
Yeah.
It's just like a standard sheet of paper.
What if we just wrote on one full side and say?
I don't want to have to flip them over to look to make sure only one side is written on. That's why I say half sheet, but you can write on both sides. That says you can write on the whole thing. I don't have to look at it. Anywhere you want to write is okay. That's basically what the gist of it. Anything you want. There's no limits to what you're putting on there.
Nice try.
All right.
Bruh.
I'm not done.
There you do no.
Wait, I'm not done. Oh.
Any other test-ish questions? So yes, Monday is a mass day. That's fine. Let's we'll do this then, you guys. We'll maybe we'll start chapter 2 on Monday then and do the test on Wednesday. Is that fine?
Yeah.
That sounds fantabulous.
Do you want the note card Friday now, or would you rather have it Monday?
Oh yeah, I guess that's a good point. Monday is fine then.
Nice. Nice.
That's yes,
That's
Matthew.
why you made it as early as you can, so that you can always move it back.
Right. So I'm changing the date right now on my Notre Dames. So we're just pushing those back a day for the test. Okay.
Hey, I didn't take it, you gave it.
All right. Everybody feel okay, right? We know what what the test is going to be on.
Yep.
We've seen the review. I know. We still have your question. I didn't forget. We've heard about the notes thing. We know when the notes are due. Sunday's homework check
Yes.
is the whole thing. So I think we're up through,
55.
yeah, to 55. I think I have you skipping one of the ones that has a log in it in between there. 52 is skipped.
Yes.
And should have the review in there.
And review on the.
And the review in there.
You gotta do the review.
You gotta do the review.
Do Sunday night. Do Sunday night.
Yeah. Well, I guess let's do this. Shh. That is a lot. Here, we'll put the review and we'll push the review into the next week's. Okay? I don't know why you wouldn't. Well, I guess since the test isn't on Monday, might as. Well, it'll just go into next Sunday's problem set, right? Yeah.
I don't want to
Glory. You probably still have goldfish, don't you?
No, I swear I don't.
All right. Okay. So the review is pushed into the problems. The review's pushed down to the 18th. That's the due date on the review. Now, I don't know why you certainly would want to work on that prior to the test, which is that week, but the due date isn't until the Sunday problem set. Okay. All right. Sure. And then Olivia, you wanted to talk about an asymptote question, correct? I did not forget.
50-second rule.
So let's say we have something like this. Okay? So I would start by looking at the graph in order to get an idea of where my asymptotes are. Can we stop talking? Thank you. So I'm just going to type it in. That's the normal window. Okay. So it looks like right about here I have a vertical. Do you agree with that?
Yeah.
If I count, that looks like -1, 2, 3, 4, -5. That's the only vertical one I see. Do you agree with that? Now I'm going to look for a horizontal one. It does look like there is one coming in through here, right? Like right in here somewhere. It looks like probably 2 comes in there at like a y equals 2. Okay. Now to confirm this with a table, I'm going to make just like an XY table. I'm going to pull these values from my calculator to confirm this. So I'm going to pick some values that are a little less than -5, but getting progressively closer to -5 each time. And then I'll pick a couple of values that are a little bigger than -5, but getting up closer to -5 with each step. And usually 3 values is sufficient. Okay with that, Olivia? And then for the horizontal asymptote, again, I'm going to do kind of the same thing. But here I'm going to be getting progressively smaller and then progressively bigger. And I'll use my calculator to pull those y values. Okay? All right. So the easiest way to do this with our calculator is I'm going to press the vars button. I'm going to go over to the y vars, tab, select the function option. That'll get me the y1. So now I can use this just like I would a function notation and can do like y1 of -5.1. And if I press second and enter, I can go back and just edit what I had so I don't have to climb through all those menus again. So there's those. So I have 102, 1,002, and 10,002. To me, that looks like we're going to positive infinity because they just keep getting bigger and bigger and bigger. Now I'll just go down and do the other part. So -98, -998, -9,098. What does it look like is happening there? Looks like negative infinity to me as well. And that's what we're looking for a vertical asymptote. The 2 sides of it should be going towards an infinity, whether positive or negative, it doesn't really matter. Okay, they could be both the same, they could be both different. Whatever, just needs to be going to infinity. Okay with that? And we'll do the same thing now for the horizontal. So second enter, and we have -10. And then 100. Oh, that's a problem. Let's do this. I'm going to just put math and then DEC at the end of it. That'll just output decimal values, which is going to be more useful to me since I don't want a big crazy fraction. So that looks good for 211 and then 201. Looks like here we're going to 2, which is what I should be. That's my horizontal asymptote. And then I'll just go back and do the same thing for the other ones. So 10. And then here, if I press second and delete, that allows me to insert a number without having to overwrite. So it just saves me from having to go back and get that DEC again. So I have 133, 190, and 199. What does it look like we're heading towards? 2, which makes sense. So that's the evidence that I'd be looking for. Again, the calculator's handling almost all of the heavy lifting for us here, right? We're just looking at the graph, writing down our guesses as to what we see, using a table to kind of confirm that. And even if you're like, oh, if you thought maybe this was 3 and then you see in the table, you should see in the table, it's like, oh, it wasn't 3. I guess I'll just erase and write it in as 2. Doesn't mean you're wrong if your table comes out, or it means you're probably wrong if your table doesn't support your guess. You know what I mean? Does that feel okay, Olivia? So again, pretty easy thing to do. You just have to be pretty calculator fluid or whatever, learned. But the calculator does most of the hard stuff for us. Okay, anybody else with questions on stuffs? Okay, so we talked about the test format. We talked about the half sheet. We talked about the test date. We talked about what homework is due. I think that covered everything, right? Okay. We got, what do we got, like 25 minutes or something left in here. I would say you can spend that time working on your half sheet or your homework or the review or whatever else is the highest priority math thing for you to be working on. And then we'll see you guys on Monday in our mass uniforms. Matthew. Certainly. Emma. You can go too. Patrick, you can go too.